All right, good afternoon. We're going to do a couple more examples here. Actually, this is your worksheet for this week, or at least for the day. If you are in my class, I urge you to not watch this video first and to try the worksheet. So this is here as a key, and it's here if you get stuck. Okay, and I understand that these problems can be a little bit on the difficult side and or the tedious side, so they can get stuck. So let's go ahead and start this. So what I'm going to do is I'm going to go ahead and multiply. Okay. Oops, we're going to go ahead and leave that alone. We're going to multiply equation 1, okay, by -1 times equation 1. So we end up with, or actually we're going to multiply by -3 rather, sorry about that, -3. So we're going to get a -3x plus 3y minus 3z is equal to -24. We're going to leave equation 2 as is, so that's just going to be 3x plus 3y minus 9z, and that is equal to -6. When I go ahead and add those together, the x's cancel out. We end up with a 6y minus 12z, and that is equal to -24 minus 6. That's equal to -30. All right. Then what we're going to do is we're going to go ahead and multiply -7 times equation 1. We're going to leave equation 3 by itself. Okay, so we have a -7x, okay, plus 7y minus 7z is equal to -56, all right? And then for equation 3, we're going to have 7x minus 2y plus 5z equals 39. And when we take care of that, again, the x's cancel. That's the important part. We have a 5y, -7 plus 5. We should have a minus 2z, and -56 and 39, I believe that is -17. Okay, yeah, we're okay there. Okay, now remember, this is my new equation 2. This is my new equation 3. All right. You don't have to summarize this. I'm just doing this because it's the first time, it's the second time through all of these things for us. So just to keep things kind of tidy, we'll go ahead and push that in there. Okay, equation 2 is 6y minus 12z. Okay, minus 12z equals -30. And I've got a 5y minus 2z equals -17. So you can see the x's are now gone. The next goal is I'm going to get rid of this y. Okay, so what I'm going to do is I'm going to say 5 times equation 2. Right, did I do 5? I did 5. So that's going to be 30y. Okay, 5 times 12, that's going to be -60z. And then 5 times -30, that's going to be -150. Okay. Equation 3, we're going to say -6 times equation 3. Okay, that's -6 times that, and that's going to give us a -30y. -6 times 2, that's going to give me a plus 12z. And then -6 times 17, that's 60 and 42, which is going to be 102. Yeah, okay. So that is, that's our next goal there. Okay, we're going to go ahead and add these together. So -60 plus 12, that's going to give me a -48z. And then -150 plus 102, that's going to give me a positive. Now it's still going to give me a negative, equals a -48, all right? And then when we go ahead and divide both sides by -48, we get z is equal to 1. So again, I'll summarize, but I wouldn't normally summarize all of this at this point. We'll have x minus y plus z equals 8. Our new equation 2, what was that? That was 6y minus 12z equals negative 30. And then we finally have a z equals 1. And that's our triangular shape there. That's what we're looking for, is that triangular shape. All right. So we're going to keep going a little bit. All I'm going to do now is back substitute. So we're going to have 6y minus 12z, right, which is negative 30. We're going to have 6y is equal to, what are we going to have here? We're going to have negative 30 plus 12. Negative 30 plus 12 should be negative 18, right? And then divide both sides by 6, and we get y is equal to negative 3. All right? And then we plug this back into the first equation. So we have x minus a negative 3 plus z. What was z? Z was 1 is equal to 8. So x plus 3 plus 1 equals 8. X plus 4 equals 8. X equals 4. Okay. So my solution here, okay, and again, you don't want to have people looking all over for this. X equals 4, y equals negative 3, z equals 1. And that's our solution to that problem there. All right. So number 2 is a little bit harder. Okay, when I say a little bit harder, I'm not kidding. Okay. This one is going to give us a little bit of a fit. What I'm going to do, because I think the last problem worked out pretty well, is I'm just going to swap the order, because these are not magic in what order they've been put in. So I'm just going to swap equation 1 and equation 2 here. So my new system is going to be negative x1 plus x2 plus 12x3 minus 4x4 equals negative 5. I'm just going to write the second equation first. This is now my new equation 1. My equation 2 is going to be 2x1 plus x2 minus 12x3 minus x4 is equal to 16. And then I'm not going to do anything with equations 3 and equations 4. We're just going to leave them as is. Okay, we don't really need to write this all out. Okay. And the reason I did that is so because I could just multiply equation 1 by some constant and not have to worry so much about trying to track a bunch of variables or track a bunch of scalars to multiply this by. Okay, so we're going to take 2 times my new equation 1. So that's going to be negative 2x1, okay, plus 2x2 plus, what is that? That's going to be plus 24x3, okay, minus 8x4. Don't forget the right-hand side, and that's going to give me a minus 10. All right, so that's what we're going to have there. My equation 2, okay, this was 2x1 plus x2, okay, minus 12x3, okay, minus x4, and this was equal to 16. Let's go ahead and add those. So the x's get knocked out. We get a 3x2. 24 minus 12 is plus 12x3. Minus 8 minus 1 is minus 9x4. And negative 10 plus 16 is equal to 6. All right. Now for the next one, we're going to go ahead and multiply my new equation 1 by 3. So this is 3 times equation 1. And we're going to look at equation 3 here. So we have negative 3x1, right, plus 3x2, all right, plus 3 times 12, that's going to be plus 36x3, okay? And then minus 12, 4 times 3 is 12, so minus 12x4, and that is equal to negative 15, okay? My equation 3, I didn't change that from the beginning, so that's going to be 3x1 plus 2x2 minus 16x3 minus 3x4 is equal to 25. Let's go ahead and add that together. All right, so those cancel. We end up with 5x2. Okay, let's see, that's a plus 20. Yeah, plus a 20 x3. Okay, and that's a minus 15x4, and that is equal to 10. All right, and then we're going to deal with equation 1 and equation 4. So this is going to just be equation 1 and equation 4 here. So we're going to have negative x1 plus x2 plus 12x3 minus 4x4 is equal to minus 5. Equation 4 was x1 plus 2x2 minus 5x4. There's a 0x3 here, okay? And that was equal to 11, right? All right, beautiful. So we end up with 3x2, right? The x1's cancel, so we end up with 3x2 plus 12x3, okay, minus 9x4. Oh, that's a terrible x4. All right, minus 9x4, and that's equal to 6. And at this point, you say, wait a minute, why are those the same? Okay, well, sometimes that happens, all right? Sometimes that happens. So let's go ahead and rewrite our equations here. So what we're going to do is just to summarize, okay? So we're just summarizing here. We've got a minus x1 plus x2 plus 12x3 minus 4x4. This was equal to negative 5, right? Going back up here to check it. Yeah, that was our equation 1. Our new equation 2, right? This is now our new equation 2. This is our new equation 3. This is our new equation 4. Okay, so let's go ahead and write that down. So we're going to have our new equation 2, which is going to be 3x2, okay, plus 12x3 minus, oops, hold on a second, let me line those up. Okay, the advantage of doing this with something with an eraser here is normally I don't think you should erase it all, but in this case we should probably erase. All right, so let's see, we have a 3x2 here, we have a 12x3, we have a minus 9x4, that's equal to 6. Our next equation is 5x2 plus 20x3, okay, where are we, minus 15x4, and that is equal to 10. And our new equation 4, okay, which is 3x2 plus 12x3 minus 9x4, that's equal to 6. All right, so let's just go ahead with our algorithm. I know that there's something that's going to cancel here, okay, but let's just go ahead along and trust our algorithm and see how far we can get with it just by not thinking, all right? So what we're going to have is we're going to do a 5 times equation 2 and a negative 2 times equation 3. All right. So that's going to give me 5x2. So that's going to be 15x2 plus 5 times 12 is 60x3 minus 45x4, and that is equal to 30. All right. we have negative 2 times equation 3. Okay. Minus 3. I don't want to do minus 2. I want to do minus 3. There we go. Okay, so minus 3 times that, that's going to be a negative 15x2 minus 60x3. Okay, 3 times 15, that's going to be 45. That's a negative sign here, right? That's the negative sign. So that's going to be a positive 45x4, and that is equal to negative 30. When I add these together, you get 0. All right, so let's just make a divider here. Okay, now we're going to take a look at what's going on with equation 2 and equation 4, right? And I think you can kind of look at equation 2 and equation 4, and if I just take equation 2 minus equation 4, we get 0 equals 0. Okay, so that I will engage the brain a little bit. So let's just summarize what we have here. We have negative x1 plus x2 plus 12x3 minus 4x4 is equal to negative 5. Our equation 2 is 3x2 plus 12x3 minus 9x4. That's equal to 6. Now, equation 3 is 0 equals 0. Okay, equation 4 is 0 equals 0. So in this case, right, our x4 has to be a parameter, our x3 has to be a parameter. So we're going to go ahead and say, well, let's set x4 equal to t and x3 equals s. Now, if you did this on a worksheet and you said x3 equals t and x4 equals s, that's fine. It doesn't matter which order you assign these in, but we do have to go back and plug them back into equation 2. So let's take a look at equation 2 with our new parameters here. So we have 3x2 plus 12s minus 9t equals 6. So let's go ahead and do that. So we have 3x2 is equal to 6, right? Plus, or we'll do 6 minus 12s plus 9t. When I divide everybody by 3, we end up with, that's still x2. What am I doing? That's x2. We divide everybody by 3, we get 2, right? 6 divided by 3, minus 12 divided by 3, okay? And then 9 divided by 3, all right? And that's my x3, all right? Now let's go ahead and plug this into, or x2 rather, that's x2. Not, let me confuse you. All right, we have x2 here. So we still got to plug this in for x1. So we have negative x1 plus, what the heck is x2? x2 is 2 minus 4s plus 3t, okay? x3 is plus 12s, okay? And then we have minus 4t, all right? So negative x1 plus x2, okay? This is 4, yeah, x2, okay, there we go. X2 is 2, dang it. Let's go ahead and ditch that. All right, so 2 minus 4s plus 3t, and then we have our x3, which is 12s, and our x4, which is minus 4t. And this is equal to what? This is equal to negative 5, going all the way back at the beginning. So let's sort this out a little bit. Okay, let's go ahead and distribute through here. Okay, plus 12s minus 4t. We're going to combine like terms next. So we have negative x1 plus 2. We have negative 4x plus 12s, so that's going to be plus 8s. we've got a 3t minus a 4t, so that's going to be minus t equals negative 5. So let's go ahead and put things on the other side. So we have negative x1. Let's go ahead and go down. Now I have some room here. We have negative x1 is equal to, if I subtract 2 from both sides here, right, we have negative 7 minus 8s plus t, right? We're going to subtract 8s, we're going to add t. And now we're going to multiply everybody by negative 1, and we get x1 is equal to 7 plus 8s minus t. All right, so my solution set here, x1 equals 7 plus 8s minus t. My x2, let's look up what that was. That was 2 minus 4s plus 3t. My x3 is just s. My x4 is just t. All right. These were completely arbitrary choices, and then we just followed through the consequence of that choice to have our x1 and our x2. All right, so this is again, this is an inconsistent system, but I've got 2 parameters rather than just 1. That can even happen in a 3x3, all right, because we could add a 1 row and then 2 rows of zeros, and we could have an s and a t even a 3x3. So that happens, but I just want you to be on the lookout for when this does happen, how do you represent it? And here we are. Okay, so again, if you peeked first, shame on you. Not really, but I hope you can try this on your own without looking. It's okay, and we'll stop there. Okay.